Hi guys, welcome to Piece of Code and welcome to this video. In this video we're going to see about string builders, and it is a very important concept with respect to core Java, and you're going to use it a lot of times, and also from an exam perspective this is a very important topic. So we're going to see what is string builder, what is mutability and chaining, creating string builder objects. We are going to see about important string builder methods, string builder versus string buffer, and understanding equality. All these topics you're going to see in this particular lecture. Okay, now let us move to our Eclipse IDE, and let me create a new class in the strings package. Let me create a new class and let me name it as string builder example, right? And let me just get this public static void main method over here. Okay, now you know how to create strings. Like this is how you create strings. So string s equals to something in a double quotations, because when you enclose something in double quotation, it's basically a collection of characters which is a string. So this is how you do it, and you know the fact that strings are immutable, right? It means that they cannot be changed. Once they are assigned, that's it. You can reassign them, but you cannot change them. That's the thing. Now let us take a small program, small example, and try to figure out how many reassignments or how many new instances of the string object is created, right? Let us see this thing. So I'm just going to take string alpha equals to empty string. I'm going to assign it to an empty string at first, and then I'm going to create a for loop. So for char current equals to a, current is less than equals to z, and then current plus plus, right? So this is the thing. Oh, I forgot a semicolon over here. Okay, so this is the thing. And then in this particular for loop, what we do is we just do alpha equals to alpha plus current, right? So we do this thing, and at the end we just do sys out alpha, right? Let me run this code. So right click, run as Java application. So you can see that we are printing from A to Z, right? That is a simple program that I have written. So try to figure out this thing. So this empty string on this particular line, right, is instantiated first, and then after this here what happens? A is appended, then B is appended, then C is appended, then D is appended, and some this kind of stuff happens. So when we are appending it, as it is an immutable class, right? String is an immutable class. We are reassigning it to that particular variable itself. So a new string object is assigned to alpha, and the previous object becomes eligible for garbage collection because that job was done. It means that what I try to saying is, initially our alpha was a empty string like this. Then what happened? Alpha become this, alpha equals to became a, because in the first iteration a was appended. So what happened to this alpha? This was ready to be garbage collected because its job is done, because it is not in use anymore. And in Java, a particular object is eligible for garbage collection when it is not in use. You are not using it anymore, right? So then what happens after A is being assigned, then it becomes AB and then ABC. So when it becomes ABC, AB becomes eligible for garbage collection, and so on it continues. This sequence of events continues, and after 26 iterations, right, because obviously the loop is running for 26 whole iterations, a total of 27 objects are instantiated, most of which are immediately eligible for garbage collection. So basically whenever a new character is appended, the previous one just gets eligible for garbage collection. But the thing is, this is very inefficient, right? Because you are just creating and you are just garbage collecting objects in a very fast manner and just going off, right? And it's not a good thing. It's not a good efficient method, right? But the thing is, you are in luck. Why you are in luck? Because Java has a solution. Java has a solution for anything, as I've told you. It's not like JavaScript. It's not like I'm dissing JavaScript, but sometimes I just hate JavaScript, whatever. But Java has a solution. The string builder class, right? What is a string builder class? The string builder class creates a string without storing all those interim string values. So unlike the string class, the string builder is not immutable. It means that it is mutable, right? Let's take an example of the same example that we have done here using string builder. So we do string builder. So that's how we create a string builder. So you say string builder. We can just say alpha max because it's the max version. You can just say whatever you want to call, equals to new string builder. So what we did here, it's just an equivalent of creating an empty string, right? That's what we did over here. The same thing, string builder. Now we're just going to copy this. I'm just going to copy this particular for loop from here and I'm going to paste it over here to save some time. And what I'm going to do over here is I'm just going to see alpha max dot append, and I'm just going to say current. Cool. So basically what we are doing in each iteration, we are appending a particular character to the previous alpha max, right? That's what we are doing. Now let us understand the sequence of things that is happening over here. Let us also display it. Let us display, what I'm going to display is alpha max. Cool. So alpha max has been displayed over here. Now let us see the output. Same output, right? Same output. But how it actually operates is actually different. Let us understand that. In this particular line, which is line number 18, right, a new string builder object is instantiated. So the call to append, this call to append on line number 20 adds a character to the string builder object each time the for loop executes, right? New iteration of the for loop executes and appends the value of the current to the end of alpha. The same thing, each time the for loop runs, it just appends the value. Appends. Now I'm not using the word reassigns, I'm using the word appends to the previous value of alpha max. The code reuses the same string builder that we had created on line number 18 without creating a new instance of alpha max every time or the string builder instance every time, right? So it just reuses the previous value. So only one instance of string builder is being created instead of creating 27 instances like we created over here. So this is kind of efficient, right? This is quite efficient and it's much faster. Okay, that's a little bit of example about string builder. I hope you guys got it. Right, now let us move forward. Let us talk about mutability and chaining. Now we're sure you've noticed from this example that we just saw, but string builder is not immutable, right? It is mutable. Obviously you've noticed it. Why am I asking this question? In fact, we gave it 27 different values in the example. Blank, it was previously blank, and then we added each letter in the alphabet, so it was 26 plus 1, 27 values. But the thing is, the exam will likely try to trick you with respect to string and string builder being mutable, right? They will try to intertwine it and make you a little bit confused, and you may fall into the trap. Now this concept actually makes it a little bit more confusing, and we had discussed this concept in the previous lecture also on strings, and the concept is chaining, right? Chaining. Now chaining makes this even more interesting. When we chain string method calls, the result was a new string with the answer. Now when we chained, for example, we took a string, for example S is a string, then we did a trim on it, then we did 2 uppercase on it. So what is the return value of this particular operation? It's a new string. So basically this doesn't operate on the current string. The current string is as it is because you cannot change the current string, right? On the other hand, it just gives you a new string value. So it's a reassignment thing, right? But chaining string builder object doesn't work this way. Instead, the string builder changes its own state. Instead of returning a new state or a new object, it changes its own state and returns a reference to itself. So you saw this example for strings, right? It is for strings. It is true for strings. But let us see an example about string builders. How does it work with string builders? If I say string builder and if I say SB equals to new string builder, right? And let's give an initial value of start. So this is if you want to give an initial value while creating a string builder, this is how you do it, right? And if you want to create an empty string builder or an empty string, this is how you do it, right? Simple as that. Now this is the initial value, and then we just append something as so sb dot append, and let us append like plus middle, right? So this is a string value I try to append, and then string builder, let's say same equals to sb dot append plus end, right? That's the thing. Now let us try to guess what will be so value of sb over here, and what will be the value of sb and same over here. Try to guess it. Let me display it over here, sb and sysout same, right? So try to guess it, right? It's very easy to guess, and as it is with string builder, I've already told you the techniques. If it had been a string, then you can probably know the answer, but as it is a string builder, try to guess the answer. Let us run the code. You can pause the video and guess the answer to by yourself. So both the sb and the same are having the same, output, right? Why is that? Because as I've told you that whatever operations you perform on a string builder, it actually operates on itself. It uses the same instance and it operates on itself. So it actually mutates itself, right? Because it's a mutable object. So when we do sb.append plus middle, then sb changes from start to start plus middle. At this point, sb becomes start plus middle, right? And then at this point, start plus middle plus end is displayed. Sorry, we are appending end over here, so it will be plus end over here. Sorry. So when we are displaying it over here, so sb is being displayed as start plus middle plus end, and as we have assigned the same value to this same string builder, so same also has the same value. It's kind of a tongue twister now, same value, right? But the thing is, this particular variable has the same value as this one because it just assigns it to this, right? So both sb and same variables have the same value, right? Now the exam won't always make the code easy to read by only having one method per line. That is not the case with the exam. It is just the harsh truth, right? So this is how the exam will try to trick you. The exam may do this thing also. So string builder, for example, a equals to new string builder, and let's say I'm just going to say ABC, and then string builder B equals to a dot append DE, and for example B equals to B dot append F and dot append G, right? Now if I take the output of both A and B, then what do you think will be the output? Try to guess it. Try to guess the output. Okay, if you have guessed that they both print A, B, C, D, E, F, G, then good. There's only one string builder object here. We know that because a new string builder was called only once on this particular line where we have over here, right? So we have it over here. So what happened? So there are two variables referring to the same object, and this is kind of a tricky thing that you would see with normal objects, right? And this is what is happening with string builder also. So what happens in this case? Let us try to understand this with a diagram, and you will understand. So when you created A with the new keyword, so what happened? So a variable A was created, and in the heap, right, what happened is this value ABC ABC was created and A is pointing to the same value, right? ABC, right? Normal objects, like normal how objects are treated, string builder is treated also like that, and it's also a mutable object, so it's kind of the same thing. Then what happened? A new variable was created, B, or a reference variable was created, and it did what? A dot append DE. So a new string builder object was not created. Instead, what happened is that ABC became DE, because as this particular operation, this operation was performed on the same object A, so A dot append DE, so the same object was changed, so DE, so it was first ABC and now it is ABCDE. And then what happened? B now points to that particular same object, so B points to the same object because the new keyword was not used. Instead of that, that same object was reassigned to B. Now both A and B are pointing to the same object, ABCD. Now if I append B dot append F and dot append G, now we are just mutating the same or changing the same object. So ABCDE FG. So both A and B are pointing to the same object. So both are having an output of ABCDE FG. That's how it goes. So don't get confused, guys. It's a very, very important thing that you understand what goes under the hood. Right, now let us see something about string builders, right? So you already know two types of creating string builders, right? One way is to create an empty string builder, which is basically this one. Where is it? Yeah, did I lost it? Okay, this is the empty string builder, right? You're creating an empty string builder. Second one is with the initial value, like this one. You already know this. Let us see a third way of creating a string builder. So let us do this thing. String builder, let's say it S3 or SB3 or SB3. Let us take SB3 equals to new string builder, and let us give 10 over here. Now let us understand what does this mean. So this particular example, which is the final way of creating a string builder, tells Java that we have some idea of how big the eventual value will be and would like the string builder to reserve a certain number of slots for the characters, right? So don't think that this is the size of the string that we are going to create. Instead, we are reserving 10 spaces for our string, because we think that the string that we are going to create is going to be more or less than 10. Now comes the debate between size versus capacity, right? And it's a very good debate. Now the behind the scenes process of how objects are stored isn't on the exam. You don't have to worry about that. But some knowledge of this process may help you better understand and remember string builder. Size is the number of characters currently in the sequence, and capacity is the number of characters the sequence can currently hold. Since string is immutable, right, the size and capacity are the same. The number of characters appearing in the string is both the size and the capacity, because string we cannot change anything, right? So that's why the capacity and size of the string is same. That is the number of characters that the string currently has. But for string builder, right, Java knows the size is likely to change as the object is used. When string builder is constructed, it may start at the default capacity, which happens to be 16. Remember that default capacity. This may come as a question, so simple 1 mark question in the exam. Default capacity is 16 for a string builder, right? So when we see this thing, so when we see this particular thing, what do you think? We are giving a capacity to the string builder over here, right? We are requesting that, or please reserve a capacity of 10, right? Now let us take an example to understand this in a little bit more detail, right? Now in this particular example, let me just go over here and let me show you an example regarding capacity. So we start with a capacity and we request a capacity of 5, for example. So we do string builder SB. So I'm just in shortcut, I've written a string builder SB equals to new string builder, and we give an initial capacity of 5. So what happens in this case? Capacity of 5 is reserved. 1 2 3 4 5 1 2 3 4 5. So 0 1 2 3 4, this capacity is reserved. Then we do an SB dot append. We do, for example, we append ANIM, we append this one. So what happens? Whatever capacity is there, those capacity, those 4 characters are being filled. So ANIM, right? Now what happens when we do SB dot append? So there is only one capacity left, right? So if we do SB dot append ALS, what happens in this particular case? Should it like discard it? Should it only take one character over here? Should it only take one A, or should it take all the characters? So in this case what happens, as the capacity, as we are running out of capacity, Java adds its own capacity at the end. So it does 5 6, it increases the capacity to 7, right, and it adds the remaining characters ALS like this. So try to understand that capacity is just the initial capacity we are giving, like okay, this many characters we may have in our particular string builder, but it doesn't mean that Java will constrict to that particular capacity, because as Java knows that the size of or the length of the string builder may change. If you run out of capacity, then basically it will provide you with more capacity. So it doesn't really make any sense to create a string builder with an initial capacity, but as the functionality is there, I thought that I should explain it how it works. Okay, let us move on to important string builder methods. Okay, so let us cover some string builder methods. So let me just create a new class over here and let me name it as string builder methods, right? And we're not going to cover each and every method like we did in the strings thing. We are only going to cover which is mostly used and which is basically going to come in the exam, right? So let us cover, let us create a string builder first. So string builder SB equals to new string builder, and let us give an initial value of animals, right? And these are more or less the same as compared to the strings, like the method we saw in strings. So I'm not going to give a lot of explanation in each method because we have covered it in detail with strings. The only difference is that you can change your own string builder instead of reassigning it. That's it. Okay, now let us cover these 4 methods: character at, index of, length, and substring. These methods work exactly the same as they did in the particular string methods, right? Now we already created the string builder. Let us see some examples. So string, substring. For example, we want to extract a string out of this particular string builder. We use the substring method, right? We just do sb dot substring and we pass the beginning index. For example, I just say sb dot index of A, and the last index or the end index I'm just going to say sb dot index of AL, right? And I don't think I need any more explanation in this, because basically what it will do, it will just insert the it will just extract the substring between the starting index and the ending index, but the ending index will be -1. It means that it will include the start index. It will include the start index. So open close bracket start index and then open bracket end index, right? So it will do a -1. So sb dot index of A, we will get A is as 0, and sb dot index of AL. So AL starts from which index? 0 1 2 3 4 5. So the end index is 4. So it will extract the string from 0 to 3, which is because end index -1. So we should get the substring as anim, ANIM, right? That will be the substring. Let us see another method. Int len equals to sb dot length basically the length of the string builder or the string, char ch equals to sb dot character at, for example, 6. So what is the character at index position 6? That is 0, 1, 2, 3, 4, 5, 6, s, right? You should get the output as s in this case. Let us display all these three things, sub plus a little bit of space and then length, and then plus a little bit of space and then plus ch, right? And let us see the output. Sorry, run as Java application, and the output is anim, as I've told you. Then the length is 7 and the character at 6 is s. That's it. All right. Now, so you already know about the append method, right? So the append method just appends a group of characters or a new string to a previous string, right? So it doesn't create a new string builder, instead it just mutates the same object, right? Now the append method looks like this. So append string str, right? Let us see one practical case where append method kind of behaves a little bit differently, right? Now let us see this example. String builder sb equals to new string builder, and let us say append 1, and then for example append c, right? So now you'll wonder, you said that this is the signature of the method, but the thing is, this is one of the signatures of the append method. It has a lot of signature, because if I do append over here, then you can see a lot of signatures of append method, like it accepts almost every data type, right? Let me give this name as sb1. Okay, now sb1 dot append, let us take hyphen, then for example dot append true, right? And let us display sb1 over here. So I wanted to show you this example because you will understand how append method works with all of the data types. So it says 1c and then hyphen and then true, right? So basically what it happens is, it just converts whatever you are doing into a particular string. So this was an empty string at first, then we appended 1, so 1, then append c, so c, then a hyphen over here, and then append true, so true. So basically what it does, it just converts everything into a string. It's cool, isn't it? So basically, like in string, when we saw this thing, do you remember when we saw about concatenation? So string x equals to abc plus 1. So what happened in this case? The whole expression was converted into a string. So this concatenation acts like a concatenation operator over here, even with an integer, because you are concatenating it with a string. You are using it with a string over here. So same thing you can just think about the append method also. It just converts everything into a string and it stores it in the string builder instance, right? Okay, let us talk about the insert method. So the insert method adds characters to the string builder at the requested index. So if you want to insert a character at a specific index, then you can use the insert method. And what it does, it returns a reference to the current string builder, right? It doesn't reassign the current string builder. Instead, it returns the reference to the current string builder. Just like append, there are lots of method signatures for different types. Here is one of the method signatures. Like I showed you for a string. Let me also show this one for the string. So insert and int offset, which is the index, for example, and then you just specify the string. It works for the same for other data types also. Now pay attention to the offset in these examples. It is the index where we want to insert the requested parameter. Right, now let us see this example over here. So string builder sb equals to, let's name it as sb2, right, because we already have two string builders, equals to new string builder, and let us name it as animals, right? So we can just say sb dot insert let's take the offset as 7 and let us give it hyphen. Now what happens in this case, as the offset is 7, so 7 is the offset, so 0, 1, 2, 3, 4, 5, 6, right? So what happens, you would say that okay, there are only 6 characters in the particular sorry, is it 6, 0, 1, 2, 3, 4, 5, 6, sorry, there are 7 characters, sorry, there are 7 characters in this particular string builder, but the last index is 6, right? So you would say okay, we are trying to insert it at index number 7. Is that possible? Yes, because as you already know that string builder is mutable, right? So it can increase the size if you want. So in this case, as we are just trying to insert it after the last index, which is 7, so the output will be just after the last index, so animals hyphen, like this. So the SB's new value will be this thing, because obviously it will just modify the same object, which is SB2. Oh sorry, SB2 dot insert. Right, now let us see another examples. SB2 dot insert, and let us give the offset as 0, and then let's give the thing as hyphen over here. So what will be the output in this case? So SB equals to hyphen animals hyphen, because 0th index is basically the first index, right? So basically it just inserts at the first index. Right, now let us see another examples. SB2 dot insert, and let us give the offset as 4, and here let us take a hyphen over here. So 4 is what? So 0, 1, 2, 3, 4. So it will just insert between I and M. So at the fourth, so after 0, 1, 2, 3, so fourth one is that where my cursor is there, right? So it will just insert it at the 4th index. That's it. 0, 1, 2, 3, 4. It will just insert it at the 4th index. So the SB value will be what? SB equals to hyphen ANI, then a hyphen because it is the 4th index, and then MALS. Okay. Now let us see the output of SB2. Why am I writing SB over here, man? It is SB2. Right, let us see the output over SB2. Sorry, we forgot this one. So hyphen ANI hyphen MALS. This is how the insert method works in string builder. Right? Okay. Now let us talk about the delete and delete character at. Two methods, very important methods. So delete and delete character at, these two methods. So the delete method is the opposite of the insert method. It removes characters from the sequence and returns a reference to the current string builder. The delete character at method is convenient when you want to delete any one character. So the signatures are like this. So delete int start and int end. It's kind of a, you can compare it with the substring method, right? And the delete character at int index, basically it will delete that single character at that particular index. Let us see an example then. String builder SB3 equals to new string builder, and let us say take this one A, B, C, D, E, let's say F. Let us do this thing SB3 dot delete 1 and 3. Right? What do you think will be the output in this case? So what is the first index? So 0, 1, this is the first index, right? So 1, 2, 3. Right? Now what will happen? It will delete from index number 1 to index number 3. So the output will be what, or the new value of SB3 will be A, D, E and F, right? A, D, E and F. So A, D, E and F. Now you may ask the question, right? It says 1, 2, 3. So 0, 1, 2, 3. Why is D still included? Why is D still included in the output or the value of SB3? Now as you saw in a particular substring method, that the end index is open bracket, right? So -1. So here also you have to do a -1. So if it says 1 3, then you have to delete the characters from 1 to 2. That's how you're going to write it in the exam, right? Okay, let us see this example. sb3 dot delete character at. That is the method we are going to see, character at, and let us say the index at 5. Now let us see, in this case, what was the previous value of sb3? It was a, d, e, f. Now the indexes were what? Indexes were 0, 1, 2, 3. We are trying to delete a character at index number 5. There is no index number 5. So in this case, it will throw an exception. Basically, it will throw an index out of bounds exception, because the 5 index doesn't exist. If you try it out, then index out of bound exception, string out of range, right? So that's how what is going to happen in this case. Let us just comment this out. So this was the methods about delete and delete character at, right? Let us move on to reverse. Okay, let us talk about one of my favorite methods of string builder, guys, and it's, yeah, my favorite method because it is known as the reverse method. So basically the reverse method just reverses the string builder, that's it. So if I do sb3, not sb3, let us try this out, sb2, right? Let us, if I do sb2 dot reverse, then it will just reverse this particular string. It will just reverse, and you don't have to write a single line of code or the logic for the reverse. So that's why it's my favorite method. So if you see, it's just reverses the string, right? Pretty simple. And there is one more method that I want to discuss, that is the toString method. So string x equals to, I can do sb2 dot toString. So it just converts a string builder to a string, right? So now it went from mutable to immutable, because string is immutable, right? So if you want to convert a string builder to string, just use this method. Okay, now that was all about the methods about string builder, guys. Now let us talk about a very interesting thing, that is it is also a very interesting interview question also people ask, that is a string builder versus a string buffer. So string builder versus string buffer. Why do we have two different mutable classes for string manipulation? Because we can do the job with string builder, right? Why do we need string buffer? Now when writing new code that concatenates a lot of string objects, you should use string builder. Now string builder was added to Java in Java 5, right? Because string builder is a mutable class and it was introduced in Java 5. If you come across older code, you will see string buffer used for this purpose. So string buffer, you can say the brother or the elder brother of string builder, you can say. Now string buffer does the same thing actually for this purpose, but string buffer is more slow because it is thread safe. What do you mean by thread safe? You have to dig a little bit about multi-threading in this case. Now for example, right, there is a data ABC, right, and there are 3 threads. Just consider threads are as different programs, okay? So thread number 1, thread number 2 and thread number 3, and they both, or they are accessing this ABC all at once, right? So what happens is that if this thread manipulates the value of ABC, then this particular thread will get the manipulated form of this ABC. For example, 1 added a D to it, now it is ABCD. So 2 will not get the original value, that is ABC. So what happens with string buffer is that string buffer is thread safe. So what happen is that so 1 will be operating on ABC. Only one thread will be operating on ABC at that particular point of time. So at that particular point of time, 1 will be operating on ABC, 2 and 3 will not get the chance to operate on ABC, right? So what will happen? Only 1 will be able to modify ABC. Then after some time, for example, now the value became ABCD, for example. So you know that that thread actually changed the value of ABC. Now the second thread will try to change the value of ABCD now, because this thread will get the control now, right? Then the third thread will get the control. So this was the case with string buffer. It is thread safe. But with string builder, there may be n number of threads. I don't care how many threads are there. Everyone will be getting the access. So it is much faster, because at a single point of time, not a single thread is actually accessing it. Now sometimes you can also question that why isn't it safer to use string buffer? I would say yes, but there are also other good techniques where you can make a particular resource thread safe. There is a synchronized keyword. You can make your class synchronized or your method synchronized. You can use a lot of things like that. So why will you go for a slower thing than a faster thing? That was the difference between string builder and string buffer. So string buffer is just thread safe, right? Okay, so that was about string builder and string buffer.